So what we're going to be looking at now is sketching the graph of a sine function where the b value is not equal to 1. So we'll just essentially have a change in the period from our parent function. So let's take a look at the graph of y equals the sine of x over 4. So the first thing we want to do is figure out what exactly our b value is. So just simply rewriting this as the sine of 1/4 times x, essentially the same thing. It becomes pretty apparent here that our b value is 1/4. So once we've determined what our b value is, it becomes pretty straightforward determining what the period of this function should be. Just keeping in mind that the formula we have, that the period of any sine or cosine is simply 2 pi over whatever our b value is. So in this case we'll have 2 pi over 1/4, which after we simplify it down works out to be 8 pi. And now that we've got our period to be 8 pi, we can go ahead and label our axis since we have the freedom to do that here. And let's just make sure that we include one full period of our sine function. So starting at 0, we want to make sure we carry it all the way out to 8 pi. And we'll just mark this out here as 8 pi. Keeping in mind that pretty much any key point on a sine or a cosine graph occurs basically at the quarter values throughout the period. So if one period takes up 8 pi, we know something important will be happening here at the halfway point, 4 pi. And then something important will be happening between 0 and 4 pi. Halfway between would be 2 pi. And halfway between 4 pi and 8 pi would be 6 pi. So we don't exactly know what will be happening at these key values yet, but we know something will be happening there. And also looking at the fact that our amplitude for this sine function is 1, essentially 1 times the sine of x over 4, we know that our maximum value will be 1 and our minimum value will be -1. So now we have our axis set up, the only thing left to do is graph this. Since we know that the sine function always starts when x is 0, we'll have a x-intercept, and from there it will go up to a maximum since there's no reflections taking place, and then it will come back down to an intercept, and then down to a minimum, and then back up to an intercept. And we've got our 5 key points on the graph. All that's left to do is to connect these up with a nice curve, and we have a sketch of our sine graph of y equals sine of x over 4.